Hey, hello champions, welcome to day one and session one on Docker Series 1.0. So today let's get started with understanding of what is Docker and why Docker. And today when we start, we'll have a quick kind of flashbacks, just like, there's a flashback in a movie. So movie starts from the mid and then you have a flashback. So we'll also go into a quick flashback, but first let's understand what's Docker by definition. So quickly sharing my screen. And if you are able to see my screen, just type Y for yes in the chat. Are you able to see my screen, guys? Okay, great. Thank you so much for the confirmation. So quickly understanding what is Docker. Now, when I talk about what is Docker, let's understand the definition and then we'll understand the real need of it. So what is Docker? Docker is a containerization platform for developing, packaging, shipping, and running applications. It provides the ability to run an application in an isolated environment called a container, makes deployment and development efficient. Now, this is what the definition says. Okay, that's why I said, we'll go in a flashback. And I know this might make a little sense to you, but what is this Docker, containerization? So we'll understand when we hit containerization correctly. But to explain you quickly, let me come back to, this launch and let me come back to this diagram. Okay. Now, though we'll be going on, we're talking about the same thing when we discuss about the architecture, but I want you to imagine this. So today, when we have multiple applications, the thing is there are many machines, and on top of machines, each machine, each virtual VM has their own OS. So imagine you create 10 EC2 instances. So you see all those 10 EC2 instances, if those are Linux, all those 10 EC2 instances have Linux operating system installed on it. But instead of that, can you imagine something like this? So imagine this is one of the machines. It has got operating system, let's call Linux. So since the operating system is already installed, now this is called a container. Now think of this container as an application. And I want you to imagine as many applications as you can. To quickly talk about few, let's talk about WhatsApp, Facebook, Twitter, LinkedIn. So imagine this each container as an application. So WhatsApp, Twitter, Facebook, LinkedIn. Now I'm assuming the case that this application works on Linux and Microsoft OS both. Okay, Windows OS both. So if considering that if this is Linux, you see all these four containers, the applications, all of these are using the same operating system. Okay, so this makes this application a lightweight application as compared to the first example which I gave you. So imagine four EC2 instances. Now each EC2 instance has got its own operating system, and both like four of them have the Linux. You see a lot of space wasted, resources wasted because you have installed the operating system 4 times, and that too on different hardware. Here we have the same hardware. Now, how it is same? I don't want you to think about it because we'll have a flashback. I'll get you on the hardware side. But imagine now this four applications are using the same operating system, but each one of them is isolated with each other. So can you see the boundary here? Which means one application, though they are sitting on the same machine, they cannot talk to each other. They are in an isolated environment. So WhatsApp does not interface with Facebook. Facebook does not interface with Twitter, and so on with LinkedIn. Okay, all four are isolated, or all 10 of them are isolated, and at the same time, they have their own libraries. So now, if I come back to the definition, okay, what is Docker? Docker is a containerization platform for developing, packaging, and shipping and running applications. So if you see here, we are developing our own application, packaging, which means all those are packaged in a way that they are in an isolated environment. One does not disturb other, though virtually, like if we talk about physical machine, they are on the same physical machine, but they're still isolated. And what they are doing, they are running applications, different applications. Okay, it provides the ability to run an application in an isolated environment called container. Got it? I explained you that container. That is an isolated environment because one container does not interfere with other, and yet both of those containers, or all 4 or 10 of those containers, are sitting on the same physical machine. That's Docker. Makes deployment and development efficient. So it's not only makes it easy to deploy those applications, even the development becomes easy. How? We'll see that when we hit the development and deployment process. But right now, this is what Docker is. This is what it means in layman terms. But now let's come back to the question that, why do we need Docker? Like, what led us to Docker? Because in Terraform, I explained you how we, moved from a bare metal to coming up to cloud. Now let's talk about what is that led to the need of Docker. Okay, so let's talk about a story once again. So how many of you are coming from a developer background, or you have been associated with developers, just FD for developers? How many of you know the SDLC, software development life cycle, which means the software, developers create some application, and then there is someone to test it, QC, QA, and all those application, and when that is tested, that's when you agree on the release date, and that's how the deployment happens. Again, I'm talking at the surface level, but how many of you have been developers? Or maybe have been associated with developers? Just type D for developer in the chat. Now, trust me, even if you're not associated, don't worry. I'll still make it simpler for you. But here is how a development cycle happens. Okay, so developer creates an application. So imagine you are a developer. Okay, now when you are a developer, what I am talking about is, so when you want to create an application, now think of this application as, when we installed Apache, or when we install databases, we connected front-end web server with databases. Now I know these days that's the connection is not happening, that the WordPress is not working. Imagine an application. When you have an application, you have a front end. So imagine a front end is Node.js. Okay, this is by the way, this is a symbol of Node.js. Okay, this, let's call, there's a database, and this, imagine a database of your choice that can be MySQL, DynamoDB, or any database that you can think of, maybe Oracle. And then there are some, Python scripts sitting on that. Plus, on top of it, you are writing your own code. It may be Java, .NET, whatsoever. Okay, so you see, the developer works on entire framework, front end, back end, the application, the middle layer, and that's how you create an application. Okay, so all those applications are packed, compacted, and created. You create a build, you deploy it, and you are able to run that on your machine. Okay, so when your app is success, this is the kind of feeling you have. So you do a lot of try, test, failure, and when all those things connect together, the front end, like I said, Node.js connecting with the databases, and then you have some Python scripting plus your own, like I said, application UI, the way you are customizing your UI to have a good look and feel. So all those things, when you try and test on your machine, imagine that's a success. Now, this is how, trust me, to reach this point, there is a lot of time, energy, effort that you have spent. The developer has spent, because there is a lot more that you have to work on the each component, and the front end, the back end, the middle application layer. I'm not going into that depth, but do you see there is a lot of work that is to be done by the developer until this moment. And there's an entire team. It's not one developer working on this. There's an entire team. There's a front end team. There's a back end team. And if at all you have a complex applications, then you have a middleware team as well, okay, who works on the middleware application. But the whole team of developers is working on something to create an application. Application is a success, and now the tug of war starts. Because when the application is success, you have some version one of it, and you go back to the tester, okay, saying that, okay, the application was success on QA, okay, so it's not success on prod yet. This is your first version, and that's on your QA environment. So once it is developed, in fact, it may not be QA, it be staging first, because different companies have different hierarchy. So it was a success on staging, and then you go back to the this tester. So there's a QC team, quality control, quality analyst, a team of testers sitting, and you just inform them, okay, we have deployed it, the first version is out here, and then you ask them to test. Okay, now here is what happens. So the tester is ready to test it, and now what happened? Tester on the go. So tester, what this person did, he copied that code from you, okay, and the entire code. Now, usually this code is in the form of build, okay. So all this, what you do is the developer packages this in the form of build. Now, this complete build is shared by the developer with the tester, and the tester installs this on some other machine. And when the tester tries to test the same application that you have written, something to his surprise is the code breaks, which means the tester is not able to see the same output that you are able to see. How many of you have experienced this? There is a constant tug of war going between developers and testers, which means developers we're like, okay, it worked for me. But when a tester tries, tester says, okay, this is not working. Now, when I say it's not working, I'm not talking about the UI not coming up because that's a layman thing, but some functionality may be not working. It might be a login, it might be a connect or any of the tabs which is not working, or the UI interface would not be as seamless as as you could see as a developer. How many of you have experienced this? I could see Yashi here. Thank you so much, Yashi. How many of you have experienced this? Just ready for experience the chat. So developer creates something, and when tester creates or raises a bug, that's when the real tug of war starts because the developer starts giving you bugs. Then people take it personally, and then people realize, okay, this it will work for me, but no one trusts you. But this is what happens. Now, why this happens? Now, to show you, to talk about few reasons, it might be due to some of the dependencies. When I say dependencies, I'm talking about, you see, though the code is same, but the hardware is not same. Okay, which means your laptop, when this code was not working, you installed some plugins, you installed some, C library files. Now, this might be missing on the tester's background, which means the hardware, and it's not only the hardware, but even the environment is not same. Imagine that, to explain you this in the layman terms, imagine I give you some phrase to read. Okay. Now, when I give you some phrase, English sentence to read out, if this person knows English, he'll be able to read out and interpret. If this person doesn't know English, which means, you see, the dictionary is missing. While you are able to read a simple phrase and you're able to interpret its meaning, the other person would not be able to interpret because he doesn't know English. He would get confused in finding the meaning of those words to get the complete sense of that word, right? So you see, the library is not same. The dictionary is not same. That's why when what happened is when developer was creating some application on his laptop, maybe on the go, you installed many plugins, you installed some libraries. Now those libraries are missing on the tester. And by the way, you never listed them and those are missing. That's why the application failed. So in a nutshell, you know, what happened is when tester again comes back to you, here's the story that goes in most of the IT industry that, but it was working on my machine. And then, that's where the thing starts. But this is what the chaos was there earlier. Today, you won't see because today we are already from last 9 to 12 years, we are already in the world of Docker. But yes, this is a chaos that was going on and on, the tug of war between developer and tester, and it had no end. But that's when the solution came in, and the solution was Docker. And though the solution is Docker, but I would want to show you this meme. Okay, now this expresses the condition of a developer because you know what? When there was no Docker and this situation was encountered, developer felt so ashamed when that application broke for QA that he felt like, okay, no one is trusting you, which means you are lying. The application never worked, but it worked on your machine. And when the developer said, okay, it worked on my machine, the common answer, now look at this meme, the common answer that QA would give you, then should we ship your machine? That was not possible. You cannot give your machine to the developer, to the tester to try and test on the same application because now the code has to be used on different machine and the code should be reusable. It has to be deployed on a production environment, which definitely not would be your machine. And that's how Docker was born. Okay. So in a nutshell, if I quickly show you, if we quickly summarize, there was a problem in the market where developer, even after working so hard creating some applications, after connecting the middle layer front end and the back end, they created something that was successful but which went for testing, led to the failures. And again, it was not something that failed due to the application code. It was the failure due to some plugins, some libraries missing, which means the environment of the developer, and I'm talking about the software and hardware environment, the environment of the developer machine was not same as tester, which is what led to this situation. And that's how Docker was born. How many of you this makes sense? Just a MS in the chat if that makes sense. because this is what led to the rise of a containerization, which means there has to be something so that the platform has to be same, which means imagine the same application that you are testing or the developer is testing. Imagine both of you are testing on a similar environment, though machine would not be same. So your machine, your laptop is different than hers or his. But how many of you agree that if the platform is same, if the machine, if both these machine had, how many of you agree that if both these machine had the same plugins, same libraries, does it make sense that the application would be success on both the hardwares? If you agree on that, please type A for agree in the chat. Which means what we are trying to achieve here is a similar kind of environment in terms of software or in terms of hardware, so that all the plugins, the environment is same. Only when the environment is same, whenever you install any application on top of that environment, it would work, irrespective of whatever, whether it's your machine, whether it's your testing machine or someone else. But that's what led to the rise or the birth of Docker, because this was a problem. So again, I've not come to the solution yet, guys. I've come to the problem here. This was the problem, and then how to create this environment, how to create this situation where you can have the same environment irrespective of what the hardware is. That was the question. And now I'm going to the flashback to the evolution of containers. Okay, so if you are ready for it, just type R for ready in the chat. Are we ready to talk about how this, how Docker containers, how we hit the Docker container? Now you know the problem statement, but how these containers evolved. If you're ready for the evolution, just type E for evolution in the chat. Are we ready for the second part of the story? And we are going in the back flash, by the way. Okay, so imagine you are watching a movie, but now we are going to the back flash, where I'll help you understand how things started from bare metal. Okay, so let's have a separate recording for this. I'm stopping here.